YouTube kindly sent me some sweets which have got the YouTube logo printed on one side and blank on the other side. So I thought, what kind of video could I make with these? Well, let's have each sweet representing a radioactive nucleus. And we'll say if it lands YouTube logo side up, then it hasn't decayed. And if it lands the other way up, we'll say it has decayed. So we started with 82 sweets. We put them in, tipped them out, and we can see that quite a lot of them have decayed and landed YouTube side down. So we can take those out as they've now decayed and then line up the remaining sweets to see how many are remaining. As you can see, it takes quite a long time to line them all up or count them the first time because you've still got an awful lot of sweets left. And there I missed one that I should have taken out. But you can see now I've ended up with 44 remaining. So let's repeat the process again. Let's put all of the sweets into my other glass. And once they're in, I'll need to give those a good mix to make sure that it's going to be fair and reasonably random. And once they've had a good mix, I can tip them out. And then it's time to remove the ones that have decayed, which have landed YouTube side down. And then once I've removed all the ones that have decayed, I can line them up again and see how many sweets I've got remaining. You can see that it's a little bit quicker now because I don't have quite so many sweets remaining. And once I've lined those up, you can hopefully see that I've got 25 remaining. So let's repeat the process again. Put them back into the glass, give them a good mix around to ensure that it's going to be fair and random, and then tip them out again and see how many have decayed and landed YouTube side down this time. Fortunately, this gets quicker each time as you've got less sweets remaining. And once I've lined those up, it should be relatively easy to see that I am left with 14 sweets. As with real radioactive decay, you can see that it's going to take quite a long time for all of my sweets to decay, for all of the nuclei to disappear. It's going to take a lot of half-lives. Because in this model there is a 50% chance roughly of each sweet decaying, then each tipping out of the sweets represents one half-life passing. After that round, I was left with 9 remaining. Both an advantage and a disadvantage of this model is that one tipping represents one half-life compared with dice, where one tipping represents less than a half-life. So you have to decide the complexity you want. So there I'm down to 6 after that round. At the beginning, because we had a large number of sweets, we more or less always got exactly half of them decaying. However, now we're down to small numbers. The random nature means it won't always work out like that. Although on this occasion, it did work out that 3 of them decayed and 3 of them didn't. How many more tippings out is it going to take for all of them to decay, I wonder? So, after that one, we're down to just 1 remaining. And will that last one decay this time? 50% chance roughly of that happening. And yes, it does decay, and that took a total of 8 rounds before they had all decayed. The sweets stacked in the glasses show a bit of the shape of the graph that we'd get, but if we plot the graph, we can see the clear curved shape of the number of nuclei remaining against time graph that we would get with nuclear decay.